Hi everyone, and welcome to this OpenVelo demo. Today we are going to create a demo web application using OpenVelo. We are currently logged into a fresh system and looking at the empty project list. So let's start by creating a new project. First, we give the project a name. For this video, I will choose OpenVelo Demo. The next section is the Models tab. Here we can configure the models that should be used during the various stages of the pipeline. We have precise control over which models the implementation agent should use and which models are used for planning inside the web UI. We will choose MiniMax M3 as the default model for this project and let all stages run using it. In the repository section, we must provide the pipeline with a repository to work in. We can choose between different providers. For the sake of this video, let's use GitHub. We will insert the URL of the repository and our personal access token, which will be used for authentication. Finally, insert the name of the branch that you want the agent to work in. Inside the last tab, you can configure which Docker images should be used for the implementation agent and the tester agent. The build and test commands can be specified here, but you can also leave them empty. They will be set automatically once you generate your first plan. For now, we will just set the number of agent retries to 10. All settings and fields are well described inside the README. Finally, we click on Create Project and wait until the validation screen passes. We have successfully created the project and have arrived at the empty project dashboard. We have the option to manually create new implementation or test jobs by providing a title, a description, and the job type. However, we are going to use the planning feature to create a fresh implementation plan for our demo project. We create a new chat and give it a name. We can choose the plan mode, which will generate a full implementation plan based on our chat and all the context we give the LLM. Alternatively, if we already have a complete requirements document or spec, we can simply upload it as the baseline for plan generation. In our case, we will create a new plan from scratch and choose the plan mode. The pipeline starts to analyze the supplied repository and creates a markdown file. This file will be used by future stages to provide context about the repository. Since our repository is currently empty, the analysis is quite fast. Once the analyzer is done, we automatically transition into the collecting stage. In this stage, we can describe our idea in a chat with the LLM. We can also upload files to provide additional context, or place files inside the repository and instruct the LLM to use them. Let's briefly describe what we want to implement, and then send our first chat message. We are going to build a small meal planner with a shopping cart and weekly planning. After receiving our idea, the LLM will ask a series of targeted questions to gather as much information as possible. It provides us with predefined options and marks one option as recommended. If the provided options do not match what we want, we can always insert a custom answer into the chat box. The LLM will continue to chat with us until it reaches a solid understanding of what we really want. After the collecting stage, we can transition into the domain planning stage. This stage takes our previous conversation and all the gathered context to generate a domain plan. This plan is then used to generate the quiz questions. As you can see, it has generated 32 quiz questions for us. In the side panel, we can see the domain each question belongs to. The questions are multiple choice, and questions that have been answered appear with a check mark. The panel also allows for quick navigation between questions. If we are not happy with the provided options, we can select a custom answer and type in our desired response. We continue this process until all questions have been answered. After answering the last question, the pipeline allows us to proceed to the final assessment. The final assessment reviews all available information and checks if there are any inconsistencies in the given answers. If we forgot something, this is the perfect moment to insert it into the chat. Otherwise, we can start generating the implementation plan. The first step of the generation process breaks down the entire context into smaller functional requirements. For each requirement, it then generates a dedicated implementation job inside the plan. This design allows for the generation of plans for huge and complex projects. The planning jobs are created in parallel, 4 jobs at a time. Once this is done, we land inside our implementation plan draft. Here, we can review each job and make changes if necessary. Right now, the list only contains implementation jobs. If we want the project to include real functional tests alongside unit tests, we can generate them for the plan. Let's do that now. Our plan is now complete and contains both implementation and test jobs. The build and test commands for the project have also been generated and updated in the project settings. We can now convert the plan into executable jobs by clicking on Create Jobs. We land back on the project dashboard with all jobs marked as pending. Jobs are generated with the correct dependencies and will execute sequentially. All that's left to do is start the orchestrator and wait until the implementation is complete. We can monitor what the container is doing by opening the job card of an executing job. In the upper right corner, we can see which pipeline stage the agent is currently in. The agent operates in a blueprint to review build loop. It only exits this loop when each stage succeeds, or if the number of allowed retries is exceeded, which we set to 10 earlier. On the right, we can see the plan being executed, identifying which entries have completed and which are still to come. The build and test stage ensures that the repository is buildable and that all unit tests pass. If something goes wrong, the agent goes back to the blueprint stage and tries to fix the issue. If the stage passes, the agent transitions to the documentation stage, where it documents the project in the open knowledge format. This documentation helps successor agents save time by not having to analyze the repository from scratch every time. The final stage is the push to the remote repository. Once completed, the job is marked as done, and back on the dashboard, we can see the orchestrator has already spawned the next job. Inside GitHub, we can see the work done by the agent. We have a new push inside the staging branch. We can also see that the feature branch the agent worked in has been successfully merged. The docs folder now contains the open knowledge format documentation for the project. The agent has now finished the second implementation job, and we can see that a test job is currently running. Let's have a closer look. Clicking the Info button provides details about what the tester is evaluating. The test includes both positive and negative tests, to ensure we aren't just testing the happy path. The VNC button allows us to watch the tester in real time. The upper section displays a VNC session of the active tests, while the container logs below can be expanded for more verbose output. The job card shows exactly what is being tested in each step and what is already passed. If a test job fails, it is automatically reset to pending, and a new implementation job is created to fix it. This creates a self-healing pipeline that ultimately delivers working, tested software. Now, all we have to do is wait until all jobs have finished executing. I hope you enjoyed this short demo. You can check out the pipeline results on GitHub. The repository is public. I hope I'll see you next time.